Formal lab report worth a test grade due 1 week from Monday. Okay, so that's like the last week of school, but I'm going to check in with you throughout next week because you can do most of it already. So here are the components of a formal lab report. Obviously, you have pre-lab. I will also post this document in the Google Classroom, but it doesn't mean that you should ignore. Merely that you should pay closer attention so you don't have to reread it on your own time, because that would be horrible. Okay, so pre-lab. Obviously, you're going to answer your pre-lab questions. This is dumb stuff, right? 8.5 by 11, 12-point Times New Roman font. Okay, title page. So on something professionally that you're creating, you should have a title page. It should have a title centered a third from the top of the page, an identification containing your name, lab partner's name, course number, due date, and teacher's name located at the bottom right-hand corner of the page. So you have a page. Title of your lab report goes in the middle, approximately 1/3 of the way, and then all the stuff you normally put in your header goes down there, okay? So the idea with this is that you have a nice clean front page. Can you do this now as opposed to next Sunday night? Yes, awesome. Yes, you can, right? So you can do your title page and then it's done. Check. Okay, objective. What are you trying to do? What is this experiment about?
Making table salt.
Okay, making table salt. How?
By boiling or by heating up baking soda.
And?
Hydrochloric acid.
Okay, so you mix hydrochloric acid and baking soda, and you are trying to see if it yields the amount of table salt that it should yield according to the chemical reaction. So your job, your objective, you might want to write this down, is to verify the mole ratio of your reactions or you could say you want to compare the mole ratio of the reactions with the experimental data. Maybe and compare. EXP stands for experimental. Okay. So that's your purpose. That's why you're doing this lab. You're going to put a couple droplets of hydrochloric acid. Nobody's going to get burned. Everyone's going to be okay. You put it on there. It bubbles a little bit. Bam, you have salt and water. You have salt water. Woohoo. Boil out the water. You get salt. You want to see, does this actually fulfill what? The chemical formula and the chemical reaction, right? Products to reactants. The reactants to the products. You have to go backwards because you're left to right. If that actually matches what experimentally happens. Or if chemistry is just all made up and none of it actually works. Okay? That's totally valid. So you're going to verify that and see how well you do. Okay? So now the introduction. You can do the entire introduction to your lab report today because you have all of the information you could possibly need to know in your lab report handout. Okay? You know exactly what you're going to do. You know what the setup's going to look like. If you were smart, you would even copy and paste that setup. I posted it online. You could copy and paste it, put it in there, and say, this is my lab setup. Okay? So you're going to contain prior knowledge on this. Obviously, your prior knowledge comes from that document. Okay? Including explanation of principles, definitions, experimental techniques, and expected results. So this is the big thing I'm looking for right here. Your hypothesis. So your hypothesis lives in your introduction, and it is you saying, I think this is going to happen. How well do you think that you can do this experiment? Okay? Do you think that you're going to get 100% exactly 0 error with the mole ratio? Is it going to work out perfect? If not, how good do you think it's going to be? When you find that percent yield, Is it gonna be greater than 50% of what you expect? That would be horrible, right? Greater than 60, 70, 80, 90? I wanna know what you think you're gonna get out of this experiment. Now, we'll look over it next week, and so I'll take a look at your hypothesis, and maybe tweak it a little bit and say, I think you're shooting too low. Or if someone walks in and is like 99.9999%, shooting too high, okay? So, I want you guys to come up with a hypothesis based on the experiment that we are doing here, okay? Theories and laws, you really don't have to worry about on this. It's pretty basic, okay? Next section, you can completely write this as well right now. Materials section, so materials, all the equipment, all the chemicals, all the computer programs. You don't have to put computer programs, that's weird. I think that was like an old thing. Like back in the day, they were like, what computer program did you use? Now nobody cares. You should include your drawing of the apparatus. Then you're gonna go into your procedure. So, really important when you're writing your formal lab report, it should be in the present tense. So the temperature, or they're doing past tense now, aren't they? Oh dear, I'm gonna lose it. Third person, past tense. So even though you're writing for the future, pretend like you've already done the experiment and you're looking back on it, okay? So we took the we are taking the temperature. Take the temperature every 2 minutes is not correct, but you can give your procedure as temperature was taken. So this, I know I love bullet points. I love it. I like live on bullet points. This gonna have to be like paragraph writing, okay? So just write out the different things that are happening. The procedure, detailed statement, step by step. So from step 0, you show up to the lab to your experiment is done. What did you do? This tells me that you understand what you're actually going to be doing in this experiment. And then, this is where we stop right here, okay? You can't do anything else until you've actually done the experiment. But everything up to this point, you should be able to do. So, let's set some deadlines. So Monday, you need your pre-lab.
This Monday?
Yes. Tuesday, I want your intro. Wednesday, I want your, we should do objective and intro. Wednesday, I'll do materials and procedure. And then Thursday, obviously you'll be getting ready for the lab. Friday, you'll do the lab. And then Monday, well, we'll jump off of that cliff once we get to it. Or enjoy, not jump. Jumping off cliffs is bad, generally. You might think the water's deep enough, Dylan.
Are you
It's not.
recording this?
Yeah. I'm recording. What about poor Emma? She's gonna be there and be like, I don't know what I'm doing. And then
She's not.
Favi's gonna be like, Belanda's horrible at this. Like, he wants everything. He wants the world and he wants it perfectly formatted and then.
It's okay, it's gonna be in college.
That's true. That's how it's gonna be. Okay, so I can't emphasize this enough. The data that you take needs to be meaningful, needs to be accurate, needs to be precise as you can make it. It needs to be right because from there, you're gonna have your results, okay? So you're gonna pull 2 types of results, quantitative and qualitative. So in your lab notebooks, I know we love our tables, but you should also describe what you're seeing, what things are doing. So when you put the hydrochloric acid on there, it's going to be bubbling. So after 1 drop, did it bubble? Yes, no. That could be a checkbox, but also bubbled violently. Bubbling slows down. After 5 drops, no bubbling. After 6 drops, nothing happens. I'm bored, right? Like qualitative results, which are what's happening, you're describing it, and quantitative results, which should be more numerical. So 1 drop, yes, bubbled. 2 drops, yes, bubbled. 3 drops, yes, it bubbled. 4 drops, no. Like yes, no, totally quantitative. You can also talk about your weights is a quantitative measurement. So when you're measuring things on scales, write down what you have. They give you like a little sample on the after the post-lab, pre-lab questions. Of what information to take down. So read this beforehand so you know, okay? But that's your results. So you have information. Then you're gonna make some calculations, okay? When you make calculations, you need to put the formulas. It turns out that the exact formulas that they use here in this example are the formulas that you guys are using, which is percent yield, actual yield over theoretical, okay? That equation has to show up in your formal lab report. It's painful, I know. Then you have your qualitative results, which are like, it bubbled and then it stopped. What would happen, what happened when you added way too much, or what happened when the thing broke twice and I had to get a new one, stuff like that, okay? Finally, your conclusion, it's gonna be a concise statement saying, hey, did we achieve the objective, okay? Well, what did we set out to do? Did it actually do it? Was our hypothesis true or not? And big thing, what error did you bring into this? Or what possible error is in your project or your experiment, okay? We've done this all for like the little ones, and I've just asked you those questions. Now you're basically answering all of it in paragraph form, okay? Finally, literature cited. I mean, you can cite this document, and that's about it. And then questions, I think that's not worth it, okay? Things that Belanda will be picky about, spelling significant digits. So if your measuring apparatus or your scale only gives you one significant digit, and then you're giving me answers with like 20 because you did a calculation, you're like, oh wow, I have 20 significant digits. That's obviously wrong. So pay attention to those things, okay? Avoid personal pronouns, which means I, me, we, like it needs to be like added one drop of hydrochloric acid to the bicarbonate solution. Added 2 drops. Continued adding drops until blah, 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 okay? So you're not making it like, I did this, and then I did that, and then I'm in kindergarten, like we're past that, okay? Headings should stand out, and each section should be separated by 1 line. So all of these headings, literature cited, conclusion, results, all of those should be separated. You should be able to see clearly what the different sections are, okay? Neatness counts. Don't even use a ruler because you're typing. So make it good. Okay. And then it gives you a sample of, is class over? No, I got 5 minutes. Okay. Then it gives you a sample of what a lab report would look like for boiling point of water, which is lame, but that's fine. So you have your title, then you have all your other information in the lower right. 2001, what is that? Okay, I want it in this form. I know it's not like Englishy. I know this is not how you do things in English. I know you indent the first line and leave everything else. You double space. Horrible for scientific writing. Don't do it. I want it to look like this. When I pull up your paper and I pull up this paper, I want to see it and be like, oh, they did the same thing. Okay? So, objective, bold, next line, tabbed in, you write the thing. Skip a line, introduction, bold, tab in, write all the stuff that you have to write. If you have more than 1 paragraph, that's fine, okay? But they should all be like tabbed in and neatly written. Okay, materials, you can list them like that. I'm fine with that, okay? Procedure, I want a paragraph, okay? So this is what we did. We took this, materials, we're taking a workstation, beaker filled with 0.3 grams of sodium bicarbonate. Beaker or hydrochloric acid was dropped 1 drop at a time into the solution or into the compound. When bubbling stopped, we stopped adding hydrochloric acid, okay? This is where the picture goes, because it's part of your procedure. Make sure you number your figures. Google Docs will do that for you if you're smart enough. Maybe. I don't know. Does it do it?
How do we get the picture in there?
And copy and paste.
Should we just from the
Yep. Will it do it for you? It will not do it for you. So you have to do that yourself. Sorry. Okay. So that's that. Then you have your results section, quantitative results. You should have numbers. There should be weights and mass and moles and like good hearty numbers. You're probably not gonna have a graph, so don't worry about that. Then you should have an example of your calculation, okay? Since you only have one calculation, your entire calculation should be written out here. Notice how they showed their work. I honestly think that looks really trashy. So if you can make your equations look better than that, that would be very helpful. Okay? So that's that. Qualitative results, write a section on that. So when we added too much, the bubbling stopped, we assumed the reaction was done, and we boiled off the water. Yes?
That one's indented. Do you want us to not do that?
Yeah, I don't
Just
do
have
that.
the whole thing?
They messed up.
Oh.
Just wanna make sure.
What's I like to mess up? No, I'm just kidding. I do it all the time. Okay, then conclusion, you must address your hypothesis. We are not in grade school. I'm not gonna be like, make sure your hypothesis is highlighted. If it's not obvious to me what your hypothesis is, then you lose. So like, make your hypothesis clear, make the fact that you're addressing your hypothesis really clear. And that's that. So Monday, pre-lab questions, Tuesday, intro and objectives, Wednesday, everything else. Okay, that's it. Thank you. Sorry for letting you down, Bobby.